So now we're looking at Thinking with Math Models Investigation 2.1, and this is part B. We've already looked at part A in a previous video, so if you didn't get that part, you can go back and look at that. Now we're moving on to part B. So in the first part, we were looking at a bridge company that painted bridges. We found an equation, we looked at the graph, and we found that we could find information that related to that. In this case, we have another one that's has 3 bridges, different lengths, and then the 3 costs. And it says plot these data points and draw a line that models the pattern for the data. I'm actually going to use the graphing calculator to do that for me in this case. I'm going to put that data, those numbers you see right there, into my list 1 and list 2 in my graphing calculator. And I do that by pushing the list button and then just entering those numbers in there. If you have a TI-83, you push the stat button, it's in the same location, and then you just hit enter in the edit mode and you can enter those numbers. Once I have them in there, there's a whole bunch of things I can do with them that's very useful. One is to plot them just to see what they look like. And so to do that, I'm going to push the yellow button on my calculator, the second button, and then the plot button, which is just above it. So we have this one and this one above it. So the yellow one that says second and the one that says y equals. And you can see my stat plots. Plot number 1 is on already, which is what I want. So I'm going to hit enter just so I can enter into that. I have a plot that's on, and I have what's called a scattered data plot. This one where the little dots here. And I'm in list 1 and list 2. A TI-83 has a very similar menu. There's a few more options in it. And then if I just graph this, okay, I've got to do some things here to clear some things out. So push this and go clear. And I have my plot on. I'm going to graph it again. It's still not what I want it to be, so I'm going to go zoom. And then number 7 for me is stat. In a TI-83, it's number 9. And then there's those 3 points now that are graphed for the 3. And it looks like it curves a little bit, but it's still straight enough that I would consider that to be linear. So we got a straight line in our statistics graph. And now what we want to do is figure out what the equation for that line is. So to do that, I'm going to go back again to my second and stat and over to calculate and down to linear regression and hit enter twice. And so now I have my equation, which in this case is not quite as nice and clean as, but we can still use it. And we're going to round off a little bit just to make things simple. So it looks like we have y equals 260x. Y equals 260x. I rounded off the 259. Plus, we're going to go ahead and round that off to 7,800. Because again, this is an estimate. It's averaging things out. We'll be a little bit off. But this is close enough in this case because again, we're going to estimate where this line goes. So this bridge company compared to the first one looks like it's more expensive. It's $260. This is the cost per foot for painting the bridge. There's your feet there, feet of bridge. And this again is sort of an upfront base cost. So you pay that $7,800 and then you're paying $260 per foot of bridge that you paint, and that gives you your total cost, painting cost for your bridge. So again, all of these different parts have meaning. This is painting cost, this is the cost per foot, this is the number of feet, and then there's again this, it's our y-intercept when we talk about linear equations. It's where you start, or it's a beginning value. So we have $7,800 of sort of upfront cost to paint bridges. So we have a graph, which we did using the graphing calculator. And actually, I'm going to go ahead and put this equation that I just found into my graphing calculator and leave that plot on. And so I have 260x. There's an x button on this calculator. It's right next to the 7. So I can put 260x plus 7,800. And now when I graph this, there we go, now we got our line. So now not only do we have the dots, but we have the line that sort of passes through. It's not perfect, but it's close. It almost touches all the dots. And again, it shows a linear equation. And I can put this on a graph by hand too if I want to, but it allows me just to see that this works, that I have an equation that fits the pattern, and all of that allows me then to answer questions related to this problem, which is really what we want to be able to do. The equation helps us to make estimates, to answer questions. For example, it says use your equation or line to estimate the painting cost for a similar bridge that's 200 feet long. So if I know that the length of the bridge is 200 feet, I can just put that right into my equation. Y equals 260 times 200 feet of bridge. It's the cost per foot, or the number of feet. Here's your cost per foot, just like that, plus the 7,800 that you're going to have to pay sort of as a base fee. So I'm going to go ahead and again just use my graphing calculator. 260 times 200. Sorry, got to back that up. Times 200 plus 7,800. So $59,800. $59,800 for 200 feet of bridge to be painted. So equations very helpful. We have one more question, question number 3. So if we have $100,000 for this painting the bridge, let's see what the cost, how much bridge we can paint for $100,000. So that's again the total amount of money, the cost, or what we have, that $100,000, and we know it's $260 per foot, or times the number of feet, plus the $7,800 upfront cost. So this amount has to come out of this before we can figure out the actual painting part cost. So I'm going to take this 100,000 minus the 7,800, and that will give me the actual cost of the paint, basically, or at least of that part of the painting cost. It's not the upfront fee, which is $92,200. Remember, these are all dollars. We're talking about a real-world problem here, where you're paying something for something. So now that I've taken that $7,800 away from the $100,000, I have $92,200, and it's $260 per foot. So I got to divide by this to actually get how many feet of bridge can be painted. And again, I'm just going to put those numbers in my graphing calculator. And it looks like 355 feet of bridge for that amount of money. $100,000 gets you 355 feet of bridge painted. And so again, we started with a table, and we used the table to find an equation. And once we find an equation, then we use the equation to solve problems, which is the whole point of finding equations. It allows you to get these answers to different questions that you have about the situation. And that's problem 2.1.